In this video, I'm going to show you how to simplify expressions by combining the rules of exponents. Before we get into the problems here, let's do a brief review of all the rules that we know about exponents. First of all, we've got the product rule. So if we've got some number a raised to an exponent n, then times some number a raised to an exponent m, how can we write the result? Well, this is just a multiplied by itself n times, and then times a multiplied by itself m times. So all in all, a is being multiplied by itself a total of n plus m. So we can just stick that n plus m in the exponent for a. Alright, so how about the quotient rule? If we have a to the n divided by a to the m, how does that simplify? Well, again, a to the n is just a multiplied by itself n times, and then we're dividing by a to the m, which is just a multiplied by itself m times. So we can cancel out some a's from the top and bottom, and how many a's we're left with is just the difference, n minus m. So again, we just stick that in the exponent. Okay, on to the power rule. So the power rule, if we've got this expression a to the n, and we are exponentiating that expression itself to the m power, then how does this simplify? Well, think about it like this. A to the n is just a multiplied by itself n times. And then we're multiplying that whole expression by itself m times. So altogether, it's like we've got m groups of n a's, and the total number of a's then is just the product, n times m. So we stick that in the exponent. Alright, on to the power of product rule. So if we've got a product ab, and we're raising that product to the power of n, then how else can we write this? Well, this is AB times itself n times. So all in all, inside of that product, there are n copies of A and n copies of B. So we can just write this as A to the n times B to the n. The power of quotient rule proceeds very similarly. If we have this quotient A over B and we're raising that to the nth power, this is just A over B, that quotient times itself n times. Now, when we're multiplying fractions, we just multiply the numerator and denominator separately. So that means in the numerator, we're going to have n copies of A all being multiplied together. So I'll put an A to the n up there, and then that's divided by, on the denominator, we have n copies of B multiplied together. So then it's just B to the power of n. Alright, so let's get into some problems. First of all, we want to simplify xy cubed, that quantity, squared. Alright, so let's get into some problems. First of all, we want to simplify xy cubed, that quantity, squared. So first of all, using the power of product rule, we can just go ahead and distribute this squared over to x and y cubed. So this will become x squared times y cubed itself squared. And now using the power rule, we know that y cubed, the quantity squared, all we have to do is multiply the exponents. So x squared times y, the power would then be 3 times 2, which is 6. So there we go. That's all there is. X squared, y 6. Next up, we want to simplify the fraction 2a squared over b, that fraction raised to the third power, and then times a to the fourth power. So off the bat, we can use the power of quotient rule and bring this exponent of 3 to both the numerator and the denominator. So we'll write that as 2a squared to the third power over b to the third power, and then that's still times a to the fourth. Now in the numerator, we can use the power of product rule and just distribute that 3 over to the 2 and the a squared. So this will become 2 to the third times a squared to the third over b to the third, still times a to the fourth. Now 2 to the third, that's just 2 times 2 times 2, which is 8. So let's simplify that, just write 8. And then a squared to the third power. Using the power rule, we just multiply those exponents, so that becomes a to the power of 2 times 3, and 2 times 3 is 6. So 8a to the 6 is our numerator, and b to the third still our denominator, and everything still multiplied by a to the fourth. Now this times a to the fourth we can just multiply over to the numerator because that's really like a fraction, a to the fourth over 1. So this becomes 8 a to the 6th times a to the 4th over b to the 3rd times 1, which is still b to the 3rd. And now using the product rule, we can just go ahead and combine those exponents on the a's. Just add them together. This simplifies to 8a to the 6 plus 4, which is 10, then divided by b to the 3rd. And there we go. That is our final result. Here's some more problems. First of all, we want to simplify this expression cube root of u divided by square root of u, then times u. Alright, so the first step here is to write these roots as exponents. And remember that in general, the nth root is just an exponent, 1 over n. So this cube root, the third root of u, we can write as an exponent, just u to the 1/3 power. Same idea with the square root. Square root is just like the second root, so that's u to the power of 1 over 2. And then we're still multiplying by u. Alright, why don't we go ahead and multiply this u into the numerator first. This is really just u to the 1/3 times u over u to the 1/2. And u by itself, just regular u, that's like u to the first power. So we can go ahead and use the product rule in this numerator and combine this into just a single u raised to the power that is the sum of these two powers, sum of 1/3 plus 1. Why don't we write that out explicitly, 1/3 plus 1, and just deal with that in 2 steps. So that's still over u to the 1/2. Alright, so u to the 1/3 plus 1, well, remember that 1 here, that's just the fraction 3 over 3. So 1/3 plus 3/3 makes 4/3. So this is really just u to the 4/3 over u to the 1/2. And now we can go ahead and use the quotient rule to just go ahead and subtract these exponents. So this is u to the 4/3 minus 1/2. So now it just remains to subtract these fractions. Let's get them to have a common denominator. Here the common denominator will be 6. So 4/3, what is that out of 6? Well, just double the numerator and denominator to get 8 out of 6. And then 1/2, what is that out of 6? Well, that's just 3 out of 6. And now we can subtract those fractions. 8 over 6 minus 3 over 6. Well, 8 minus 3 is just 5. So we've got u to the 5/6 power. Next up, find k such that the quantity 3x squared to the 3rd power divided by 3x to the 2nd power is equal to kx. Find k such that that equation is correct. So really we just need to solve for k in this equation. Now before we think about solving for k, why don't we look at this big expression on the left side here. This expression looks like it can be simplified a ton. So let's go ahead and do that. Let's go ahead and simplify that. So bring it over here, we'll write it out again, 3x squared to the 3rd power over 3x, the quantity squared. So we can just go ahead and start by using our power of product rules. So just distribute this power of 3 over to the 3 and the x squared. We get 3 to the 3rd, then times x squared to the 3rd, then over, same thing, distribute that 2 over to the 3 and the x, 3 squared times x squared. Now immediately we see that we've got a 3 to the 3rd and a 3 squared. So we can simplify that using the quotient rule. Just subtract the exponents. 3 minus 2 is just 1. So 3 to the 1st power, and we don't even write 1st power, it's just 3. And now this x squared to the 3rd power, we can use the power rule, just go ahead and multiply those exponents. So x to the 2 times 3, which is 6. That's still over x squared. And hey, we can use the quotient rule again, x to the 6th over x squared. Just subtract those exponents. 6 minus 2 is 4. So overall, we've got 3x to the 4th power. So let's go ahead and write our equation again. That left-hand side just became 3x to the 4th. So 3x to the 4th is equal to kx. And now to solve for k, we can just go ahead and divide off that x from both sides. So that'll cancel out that x on the right-hand side, just get k alone. And then on the left-hand side, noticing that this x is really just an x to the 1st power, we can go ahead and use the quotient rule, x to the 4th over x to the 1st power. Just subtract the exponents, 4 minus 1 is 3, so 3x to the 3rd equals k. Let's write that around just for clarity. K is equal to 3x to the third. And there we go. That's all there is to it. We've got K. So now we know how to simplify expressions involving exponents by combining the rules of exponents. This will be very important as we begin our study of functions, because a lot of functions involve exponents.